Greetings, everyone. Um, Wait a few minutes for other people to join. Turles, you actually operating on Pacific time? Is it really 5 a.m.?
Were you asking me?
Yeah, just curious which time zone you're in. You're in today.
Oh, yeah, California. It's 5 a.m. Sorry, I was just hunting a coffee.
Yeah. Appreciate you accommodating this time slot. There's no perfect time slot for this meeting.
No, of course not. But not to worry.
Go ahead and get started. This is the Note Well slide. Needs to be shown at the start of every IETF meeting. You're expected to understand this and the policies and procedures and everything on this slide does apply to all IETF participation. Okay, so let's stop that. Now we need to go bash the agenda, because today's agenda definitely needs some bashing. Okay, so this is what we're going to do. Right now, we are in the middle of agenda bashing, and I was optimistically hoping that that would be only 5 minutes. What I need to do is quickly check which of the 7 drafts we actually have people on the call who have slides for, so we know what's coming. So Jinu sent slides for this one. That's good. Xiaofu sent slides for this one, so that's good. CSQF. I don't see Shusung on. Go ahead, Turles. Just go ahead, speak up on that.
Yeah, so I sent email yesterday and uploaded 2 revisions of the slide deck, and that's for CSQF, TCQF, and GLBF. And the 3 of us did edit and review the slides.
Okay, so we've got them. I'm not sure I saw the email. I'm not sure I was looking in the right place, though.
I
We're
sent it to the DETNET mailing list,
you
and
sent.
you were in reply to your query.
Okay, if you sent a DETNET mailing list, what probably happened is it was after the last time I looked at it yesterday, and it's sitting over in my inbox, and I'll go find it. Okay.
I uploaded it twice, so Ref 1.1 is the last one.
Okay, good. Hang on a minute. What happens if I look over here? Oh, there they are. Hang on a minute. So you want the 1.1.
Yes.
Okay, we will go ahead and hit approve on that. Okay, so we've got those. All right. At some point, we'll see how fast Meet Echo can propagate from uploading slides to presenting them. All righty, I believe I have slides for these. Okay, let's quick check. Back to here. I don't think I see Antoine. Does anybody have slides for this one, the bounded delay queuing? All right. Fortunately, luck of the draw means that's the last slot. Yeah, that would help if I could type this morning. I need more coffee. Okay. Let me say a few things about what we're sort of trying to do today, and I'm happy to take input. And if everything down here slips by 5 minutes, I think we're still okay. So we've gone through the requirements draft. We've done some initial evaluations of the TSN techniques, including the ECQF that is currently in progress there, to check that we can actually use requirements draft to do the evaluations. So the goal for today is simply to put up and discuss the initial evaluations of the new mechanisms. Um, I'm not going to try to go scoreboarding or summing up of things. The reminder to presenters is please focus on the two scalability requirements that we really don't have good solutions for in the existing TSN mechanisms. Any questions on what we're trying to do today? I think the goal is mostly information sharing and discussion. Either I'm very good or nobody's awake. It's probably some combination of the two, as there are people in time zones where I'm sure they're awake. All right. The order presentations, I went to random.org and did a random and pulled a random permutation. This is what happened. Turles, go ahead.
Get past the agenda bashing. So as I sent in the email, I in the process of evaluating the three mechanisms in my slides, I kind of ended up in revisiting some of the requirements. I already discussed this with the co-authors of the requirement draft, but in any case, I've got a section of kind of the revisited requirements that I evaluated against, and then also, if we have time for that, some concern about the existing evaluation of ETCQF. So those were the two add-on things which, if they weren't meant to be implied by the review drafts, then I'd still love to have them being discussed as well.
Okay, let's see how we're doing on timing here. The theory is we're running with about 15-minute time slots, 10 minutes of presentation, 2 or 3 minutes of questioning, and a minute or two of fumbling to get the next set of slides up. If we have time down at the end, we can do that. Do appreciate that. I do appreciate and thank you for looking at the requirements in more detail. You try to do evaluations and finding opportunities for improvement.
It's I think it's hard not to show those in the beginning, even though we can skip through them quickly. But otherwise, the evaluation template that I'm showing is going to look slightly different, and so it's rather easier to have a quick explanation on front. But given how I'm doing a joint evaluation of TCQF and CSQF, I think we're going to save a lot of time there.
Okay, let's stick with the rough plan, which is time slot per draft. Um, If the evaluation template is close to what we've got, that's fine. I mean, today's goal is discussion. We can drive towards consistency in the next meeting. Any other questions or comments? Okay, so Jinu, I believe you're up first.
Okay, great. Thank you, David. So I'll spend about 10 minutes to present. I prepared 3 slides. I'll spend most of the time on the first slide. The next 2 slides will be just the extra ones. Okay, so C-score evaluation. Before going into further, if you look on the right upper side, I have specified the end-to-end latency bound of the C-score. So it is the function of B, L, small r, H, and L max, and large R. These represent maximum burst, maximum packet length, service rate, and number of hops of the flow, and L max and R are the maximum packet length and capacity of a link. Yeah, so if you understand this equation or the mathematical representation, almost all the requirements in the requirement document could be understood very easily. So I'll start with 3.1 first. It tolerates time asynchrony. Yeah. Yes. Global time synchronization is not necessary. However, each node in the network operates its own clock, and the time difference between clocks have to be adjusted in order to properly operate the C-score. However, the time difference between nodes can be simply added to the delay factor, and delay factor is robust or insensitive to any inaccuracy of the measure TT. Actually, this aspect has been very well explained in the document. So if you have any question, I recommend to read the draft first. And 3.2, it supports large single hop propagation latency. So the propagation delay itself is a factor of the time difference between 2 nodes. And it also can be simply added to the delay factor function and can be added to the end-to-end latency bound expression above. The above expression neglects the propagation delay, but it can be just simply added. So yes, 3.3 accommodate the higher link speed. It is partial. As you all know, this C-score requires parity queue. It can be possible to sort the packets according to the priority or the so-called finish time. So priority queue should be supported, but it is about 600 gigabps Ethernet can be supported if 2.5 gigahertz clock ASIC is used. It will be more elaborated in the next page. And the more important thing here is that according to that technique, the queue length is independent of the throughput. So no matter how the queue length is large, the throughput is intact. And 3.4, yes, it is scalable to the larger number of flows. if you look at the expression of the latency bound, it is independent of the number of flows. Similarly, in 3.4.2, C-score is also independent of the flow utilization. However, utilization have to be less than 100%. That is assumed to be given. Yes. Below the 100%, then the utilization level is not affecting the end-to-end latency bound. And 3.5, as far as I understand, the flow fluctuation means dynamic flow join or dynamic leave. So flows join and leave very frequently dynamically. In such a situation, we would require automation control and resource reservation. But I believe every solution discussed in this working group requires similar procedure. And the burst accumulation aspect of 3.5 is, I believe, it is slightly different thing from the dynamic flow join and leave. But anyhow, the C-score prevents burst accumulation itself. So it's very beneficial to use the C-score in the sense the burst does not accumulate at all. And 3.6 is not relevant, I think, to the queuing mechanism. And 3.7, yes, it is scalable to larger number of hops to use complex topology. Yes, it depends on the number of hops. As you can see, it is function of h, which is the number of hops of the flow, but it is linear. So in the sense, it is scalable. For the 3.8, the C-score itself does not provide multiple mechanisms, but it copes well with the other asynchronous solutions, such as TSN ATS, or deadline-based forwarding, such asynchronous solutions. Thank you. Could you go to the next slide? Yeah, this is the region I claim that 600 gigabps throughput is possible with about 2.5 gigahertz AC. The paper I'm referring is the first author is Bagwan. It was presented in 2000 in Infocom. And the author is from University of California, San Diego. Anyway, Infocom was at that time around was the best conference, and it was very hard to get accepted from that conference, I believe. And anyway, this paper suggests so-called pipeline heap or P-heap. Using that technique, one in-queue and D-queue operation. So there are three operations. The first one is in-queue, the second is D-queue, and the third is in-queue and D-queue. And using pipeline heap, combined in-queue and D-queue can be done together. Then these all three operations can be done in only 2 clocks or 2 clock cycles. That's the main contribution of this paper. No matter how long the queue length is, only 2 clock is necessary for the in-queue and D-queue operation. And with this tedious calculation, we can conclude that with using 2.5 gigahertz AC, we can support up to 600 gigabps. Yeah. And the next slide is yeah, I've shown you this slide like 3 or 4 times, so far. Oh, but for some reason the equation has gone. I should have given you a PDF file. Anyway, this latency bound expression is similar to the one I have shown you in the first slide. So I won't go into detail, but I'm trying to emphasize that the syscore has very concrete mathematical background and all the proofs and so on. So yeah, it gives the definite end-to-end latency bound expression. And based on this expression, I can claim that all the scalability issues can be fulfilled. Thank you. That was my presentation.
Thank you. Excellent job at time management. Okay, clarification questions only. Any questions? Clearly people need more coffee, or Janu was very, very clear. I'll take success any way I can get it right now. Okay. If there are no further questions, then I guess we carry on. Deadline-based forwarding is next. Let me go find that slide deck. I think I know where it is. Hang on. Wait a minute. Meeting materials. All right, this is going to be done a little bit differently. Meet Echo says it apparently wants to use one of my browser windows to do this. So we'll do it this way. Is that the right one to start on? Yes, it is. Xiaofu, go ahead.
Hi, can you hear me?
Okay, let me just check whether I've yeah, hang on. Okay, good, that's up, and yes, I'll get the timer started. Thank you. I
Okay.
told you it was going to take a few. I told you going to take a few minutes of slide fumbling. It did. Go for it. Shafu, are you speaking? Oops. Hang on. There he is. All right.
Okay, I will continue. There's some issue to share the screen. For the first one, the evaluation is yes. But according to the requirement of the, we think that we should need a frequency synchronization. So okay. For the next one, the method two. Support
Oh dear, his network is not cooperating.
I'm sorry for that. I will go ahead. For the 3.2, the evaluation is yes. For the dynamic mechanism, the eligibility arrival of flows is independent with the linear propagation delay. And for the next I doubt can you change to the next presenter and I will change to another network.
We'll try that and see what we can do. Yeah, something is not working with your voice. I'm sorry. All right, let me go cancel that and figure out what I'm doing next here. Okay. All right. All right, with apologies for the slide fumbling. Turles, I think you'd said that all three are in this deck, and it looks like the random selection put them in order. So I guess you can do them in whatever order you like, since they're all in one deck.
Okay.
I will run the 10-minute clock per, and if we get ahead of schedule, that's even better. We can give Xiaofu more time to get his audio working. Hang on. Let me go start over. I'm busy talking and taking your time. Okay,
Yeah.
go.
Next slide. Or can I do it myself?
I have to do it because unfortunately,
Next slide.
MeetEcho did not pull the slides into slide sharing, so you'll have to
Okay.
cue me.
Next slide. Oh, this is not version 1. This is, can you go back to the, sorry, can you go back
This
to
is
the 1.1?
This is 1.1.
Wow, now
Load
I'm
up in the tool.
now the author gets confused on the wait a second, please go back to the main slide.
Wait a minute. I know what the problem is. I hit the wrong button. My bad. All right. Let's see if I just. All right. Okay, this one is the one you want, right?
Yes. Right.
Okay, sorry, I hit the wrong button. Pilot error over here.
Wow. Okay.
And let me
So
go.
we added to our evaluation a column to indicate whether the requirement is something that needs to be done in a mechanism on every hop, or which can be satisfied by doing it only on the first hop. And then we evaluated the 3.1 sub-items 311 to 314 individually, because we saw that, especially compared to other pre-existing TSN algorithm, that's where the differences are. And so it's much clearer by having that listed individually. Then I had a large issue in trying to see how to evaluate 3.1.4, because it has, I think, two good requirements, but then an implication which I don't agree to, right? So, so first of all, it talks about the no clock asynchronicity. That's already covered, I think, in 313. So the really good requirement that this point implies is the support for aperiodic flows, and that's what I basically evaluated against. But what it says is that this support for aperiodic flows can only be done with per hop asynchronous mechanisms, and I don't think this is true, because we can equally support asynchronous flows in TCQF, CSQF, or even CQF, ECQF by handling the burst either through over provisioning or through adding the latency on the ingress, and therefore shaping the burst, right? So we could stretch out the burst of flows we receive over a 500 microsecond window on ingress, and therefore increase the utilization that we can get in our synchronous mechanisms by a significant factor. So it's not necessary to use the asynchronous mechanism like RFC 2211, QCR, which is TSN ATS, or I would assume also C-score, because the problem, and GLBF, my own GLBF as well, right? Because they natively come at the price of, if you want to cover the bursts, then you need to suffer the large per hop buffers, and therefore the increased path long latency. So that is not necessarily a benefit by itself. So then I added a requirement which I think is quite significant, which is the evaluation of single hop propagation jitter support. And for nodes processing jitter at larger than 100 gigabit speeds in large router architectures, that is significant. And then we also now are getting raw, the mobile interfaces where retransmission, for example, introduces per hop jitter, length deviation. I talked about that. So I feel that that is an important evaluation criteria to check the algorithms against. And finally, which I think in the same way as we did 3.4 in parentheses 1 and 2 in early evaluation, I added 3.8.1, which evaluates the jitter on a per hop basis. So those are the changes that I did. Next slide is just the template. So if others want to use it as well. And then next slide, just for reference, is how we evaluate it. So for example, the tight jitter means that the end-to-end jitter is independent of the number of hops, 381. And likewise, the criteria that are exactly used for evaluating the other points, I think we can go back for this as reference later on. Next slide.
Can we skip this one and go to the first eval, please?
Yes.
Bingo.
Okay, so common evaluation, because they're pretty much the same fundamental mechanism, and we only got differences relevant to the evaluation on one point. So the difference in behavior are really only how the mechanisms integrate with segment routing. CSQF depends on segment routing and gets the benefit of more flexible cycle assignment. And in TCQF, we are independent of segment routing, but practically speaking, I'd very much expect that any large-scale networks will also want to use segment routing anyhow, but we can use it with MPLS-TC and IP-DSCP. So that was just the technical background. Next slide.
Hang on a minute. Hit that one. There we go.
Okay, and if you go to the next slide, and that slide is not too small in the text. One more, next slide. Then this is the version. Nope, go back.
I'm sorry. Tell me the title of the slide you want to be on. It looks like we've got some propagation latency here.
Oh, wow. Okay. I want to have the second of the two comparison. Exactly. This is it.
Okay. That's clearly what's happening.
Yeah, sorry if there is large latency.
No, it's okay.
There is no bounded latency meet echo. We need to fix that. Yeah. So this is also putting in the comparison as I revisited it for CQF and ECQF, and we can take the discussion of that offline, but it was meant to make it easier to understand why we feel that TCQF, CSQF are significant improvement over especially also ECQF. So the first one, 311, asynchronous across TSN subdomains. So we think that is an ingress function. So in TCQF, we define such an ingress function that would be equally applicable to CSQF. So it's just not repeated in that draft yet. And I would assume something similar is possible in TSN. So I put the yes into quote, although I'm not quite sure exactly if they have defined such a function. So there should maybe be a question mark. Then the second one, 312, tolerate clock, wander, and jitter. And I think that is also one of the main benefits over ECQF because in both CQF and ECQF, by not having the cycle metadata in the packet header, you're still relying on the arrival clock time to assign a cycle for the packet. And that means you either need to start doing a window of dead time or you're going to get into problems with any type of encounter, jitter, and wander. And so because we have the cycle number in the packet, we can support jitter and wander within the limits of cycle time. So if we have 4 cycles, we can support up to 1 cycle time worth of jitter and wander, short and long-term drift of clock against each other. 313, no full time synchronization required. So that is, in TCQF, CSQF partial instead of no for the TSN solutions. So we defined a yes there is something where I can have unlimited jitter and wander. And obviously that's not true because we do need clock synchronization with limited jitter and wander. But we do require a 90% lower accuracy in the clock synchronization than we need in TSN. And in TSN, that would need to go up linearly with the speed as well. So we feel also from experiment with large-scale actual deployment that this reduced accuracy makes it quite feasible. So as far as understanding the requirement against no clock synchronization to be a problem of deployment of clock synchronization, we don't see that there is a problem with the deployment of that reduced accuracy clock synchronization in our solutions. 314, support for aperiodic flows. And as I said, that is yes, but it would occur on the ingress routers. So we would need in the ingress function to have an additional lengthening out of the burst to get higher utilization. But of course, that means the overall end-to-end latency will also be lower than, for example, by those mechanisms that have to do it on a per hop basis. And that is actually something that may need to have additional detail writing in the text of our drafts, though. 3.2, large single hop propagation latency, obviously, right? So that is also something that ECQF solves, and that is, of course, something we started the whole thing out with by using multiple cycles. 3.2.1, support single hop propagation jitter. Yes, and that is, as already mentioned, a new requirement that I added there because the pre-existing solutions don't support that. And I mentioned already the different points where this is required, especially in complex high-speed routers, the processing jitter that we see when we can't have over the whole system ingress and egress line cards through distributed fabric, total synchronization, for example, then we will have jitter in processing packets received.
Okay, quick interrupt on time
Yep.
management.
Mhm.
10 minutes, first 10-minute slot is expired. Second 10-minute
Mhm.
slots has started since you're doing both
Yep.
TCQF and CSQF as a
Mhm.
combined Prezzo. Go for
Yeah.
it.
Thank you. 3.3, support higher link speed. So we have tested 2,000 kilometer, 100 gigabits. So that has been proven. We don't think that has been proven for ECQF or CQF. Obviously, for CQF, it wouldn't work in the length, but also I don't think 100 gigabits have been proven. And I think Yizhu had more details on why we felt that these things cannot be made applicable here. 341, scalable to large number of flows. Yeah, we don't have any per flow, per hop state reading and writing. Tolerate high utilization. So we don't have dead time, so that's also yes. The 3.5 link node failures, topology changes. So in the prior evaluations, we said it's not applicable, and I also saw this in other evaluations. But I think for all our solutions, even the ones that haven't evaluated yet, I would say we're much easier on the yes side, and which I feel we are, than TSN, because we have the routing framework with fast reroute, with nailing down a traffic engineered path, and TSN doesn't have this in a scalable way, right? You can only do it on a per flow basis through every hop, but we have the segment routing architecture that does do it stateless, and so it's that segment routing architecture that obviously all our solutions for scalability would need to integrate with to scale for these requirements. So that's why that's a yes. Likewise, 3.7, just to stay in line with that, that is also by virtue of integrating with segment routing, and then this is where the only minor differences between CSQF and TCQF comes in, where CSQF has some uh, possible increment in performance. 3.6, prevent flow fluctuation from disrupting service. Yes, of course, that's already the same for all the solutions. No change in additional flows changes the per hop behavior of existing flows. And then the new requirements support tight jitter sync control loops. That is also not a difference between these solutions, but I think very much a difference between these cycle solutions and the other solutions that are being proposed. So that is a really important network size independent hop by hop end-to-end jitter. Next
I'll
slide.
quickly observe that you and Tron have reached about the same conclusion, that in the area of 3.7, we need to split delay accumulation from jitter accumulation. So that's a good sign.
Okay. Right. So here are the justifications for 3.4. I think I already said most of that. We had the research paper with simulations. We had the validation with inexpensive FPGA hardware and long length. And then, of course, also the showcase for the reduced accuracy of clock synchronization that is enabling that large-scale deployment. Then because we do have the cycle number opposed to the TSN solution, the packet header, we can have the clock jitter wonder and the per hop propagation jitter as well. Okay, next slide. 3.7. Right, so the per hop cycles avoid any burst accumulation, so same thing. And this is basically the details of the explanation, where TCQF and CSQF differ. So in TCQF, the next cycle on the outbound side is fixed, and therefore, when you do the admission control, the sequence of cycles is fixed. And in CSQF, the sequence of cycles can be assigned by the controller as part of the packet header. And therefore, if you start, for example, with a sequence of 16 cycles, you have a factor of more than 10 to increase utilization up to very high utilizations in the network, because you avoid burst collisions on the path. And then, of course, the benefit of segment routing as the core DETNET overall versus TSN solution, right? Because remember, we do not have CQF or ECQF as a per hop DETNET solutions. We can't build this without having per hop state, because as they exist, they don't know what a DETNET flow is. The only thing we can do is have a TSN subdomain, and that subdomain cannot have segment routing in it, right? So that's why I think this comparison is so important but complex. Next slide. I think we should be done.
Okay.
Yep. Start a new clock if you want, or give me the 3 minutes. I don't know.
I'll start a new clock, and what we will do is, hang on, clickety, clickety, clickety. We'll give you, we'll add on the unused time. Go.
Okay, next slide.
Hang on a minute. Coffee's still taking effect. Okay, go.
Right, so this is very simple now, so I don't need to explain anything new here. So asynchronous across TSN subdomains, so it's naturally asynchronous. There is no special ingress function needed. Then the tolerate, clock, jitter, and wander, yes, it's naturally asynchronous. So in the same way as Gino explained, any differences in the clocks or so have been just added to the calculations. Tolerate asynchronicity, yes, so that is a full yes. So we can have, as in my evaluation template slide explained, something like a clock drift of 6 seconds over a day between adjacent routers and have no problem, which is what I calculated from normal Ethernet interface clock requirements, which are also not synchronized as described in our requirements draft. Support aperiodic flows, yes, so that can be done directly on the P of on every node per hop basis, like with any other asynchronous solution, at the cost of then having to provision larger buffers and latency, like all of them. Or we can of course use it on the PE with an appropriate PE ingress function to reduce the latency. The large single hop propagation latency, yes, there is also nothing special here. Support large single hop propagation jitter, yes. So in this case, we are across that hop, not asynchronous, because then we would do local clock synchronization between those nodes. I'd imagine this for wireless nodes, and they typically need to have clock synchronization anyhow between the mobile node and the radio tower, for example, at a very low accuracy. Support higher link speed. So this, I think, is the TBD, like in, I would hope we would get to in any other solution that doesn't have actually a proven implementation. So we did look, and the proposed algorithm in timed FIFOs also has a lot of justifications why we think this is very well feasible, but it hasn't been done. So that's why it's TBD here. Scalable to large number of flows. Yes, we have no per hop per flow stated. Tolerate high utilization, yes, no dead time, so we can get easily to 100% utilization on any links here. The link node failure, yes, so that's also, again, integrating with segment routing. Prevent flow fluctuation, yes, because there is no burst accumulation. The latency across every hop is accurate to the clock accuracy. Scalable to a large number of hops with complex topologies. Yes, so there is a little bit TBD here. So the flow interleaving, I'll still need to check out things. And then support tight jitter control loops. Yes, because the end-to-end jitter, of course, is also pretty much zero, because on every hop it is also very much zero. So the only thing that adds up is the per hop clock inaccuracy. If that's in the order of microsecond, then we would have, let's say 15 microsecond jitter end to end if that's being added up. Next slide. Yeah, so I think I explained all of that. No, perhaps no need for a single cycle. Read write, yeah, TSN. Yeah, so the calculus, the algebra for 3.7, that is the same as for TSN ATS QCR. And just the per hop shaper that require per hop state is replaced by damper, which we can build stateless. So that also makes it very easy to I think, work in TSN environments and with a TSN built controller. And yeah, so the high utilization that TBD is under review. So that's pretty much it. I don't think that the 9 minutes is, I don't think I spoke just 1 minute here. Something's wrong with the clock, but in my favor. So I don't think there's any more slide here other than the reevaluation. You can click forward to an eCQF slide if you like to. But
the reason for the timing is I credited you the 3.5 minutes that you hadn't used out of the first one.
Oh, okay.
All right. So, all right. I guess we can go ahead and use this time for that. But why don't we stop here? Let me go pause your clock for a minute to see if I can do that. See, take any question what we've done so far.
Yeah, that's much better.
Hang on. All right. There were about 8 minutes there. Any questions on what's been gone through so far, aside from it looks like we need another round of work on the requirements draft? Janu?
Thank you, Toles, for the nice presentation. I have a question for clarification. Do you have any mathematical expressions for end-to-end latency bounds for each of the mechanisms?
Yeah, so the cycle mechanisms, I think, are very simple to understand, right? So that is the, the mass that we have in our draft. So it's just, the cycle time, you add up the cycle times, and of course the propagation latencies. So that is very simple math. And in GLBF, it is exactly the same math as for UBF, which is the algorithm used by TSN QCR. So that is also simply the sum of the burst buffers for the different priorities. So the math for both of them is extremely simple.
Okay, so the cycle-based mechanisms are just the hop count times the cycle time. That's what you're claiming.
Yes. Yes.
Okay.
Times the cycle time, meaning
next...
the number of cycles, right? So on every hop, you can have, let's say, 2, 3, or 4 based on configuration times the cycle as queuing propagation latency.
Okay. So my next question is, how do you decide the cycle time? Can it be arbitrarily small?
So what you need to do is you need to make the next cycle larger than the propagation latency plus any jitter that you have. So these things we showed in slides several times, and I hope they're good enough defined in the draft. So if not, please let's fix that in the draft text.
Is it dependent on the number of flows or the utilization level?
No, not
For
at all.
example, if the number of flows are very large and the flows come together, the packets of the flows come together at the same time, if that happens,
that is what I exactly... Oh, sorry. I think we again have a lot of latency here in Meet Echo. Sorry, didn't want to talk over you. No, but this is exactly what I was saying. I think if you read draft Eckert DETNET flow interleaving, that is exactly talking about that problem, right? So if we have a lot of aperiodic flows with a very low rates, but let's say once every millisecond, one packet, and you have 10,000 of these flows, then the only thing you can do is either provision on every hop, the worst case that all 10,000 flows have their burst at the same time, or you start giving them some added latency somewhere so that the bursts are decorrelated. That's a generic problem without that we have whatever algorithm we use. Now, when we use a cycle mechanism, we are deciding on decorrelating these flows on ingress, right? And not on every hop. If we decorrelate them on every hop, like we would do, I think, in C-score and in GLBF, then the cost of that is higher buffer, which is maybe a good thing, maybe not, right? So I think that is an ongoing debate where you need to look at the math of your traffic load.
So in order to remove the necessity of the decorrelation, you have to hold the packets at the network entrance and put it
No,
at
what I'm
the
saying is if you decorrelate them on ingress, you don't have to do it on every hop. Remember, when you're looking at the fact that every hop could have potentially 10,000 flows, which send a packet only once in a millisecond, right? Then you still need to have for the buffer size, for the burst size of each of these flows, the buffer there, because they could just by random loss of draw or occur all at the same time. And then you need to buffer them all up, right? So do you want to have all that amount of buffer there? I think when we do the calculation, we'll see that we maybe do not want that. And in the cycle-based algorithm, we're deciding that we never do that, and we're decorrelating them on ingress.
Yeah,
And
my
that's typical
impression is
large-scale network solution, right? So typically in a large service provider networks, we're doing the difficult things, like in this case, the new difficult thing would be decorrelation through the frame interleaving, right? So we would be doing that in ingress, like we also do with the pre-off function. We're doing
I
that on
understand.
ingress, not egress. Mhm.
So if I understood correct, at the network ingress, you are adding another kind of delay to
Yes,
the
and I'm assigning that from the admission controller. I'm basically the admission controller
has to
decides
be,
in
I
which
think,
time window within 500 microsecond, for example, a particular flow's bursts are being led into the network.
yeah. Anyway, the extra delay occurred at the network entrance has to be
Exactly.
considered as
Yes.
the end-to-end latency. That's the one thing I have to mention.
Yep.
And the second one is that GLBF, the mathematical expression for the latency bound for GLBF, is not the same with the
No, it's
TSN
not.
ATS.
No, it is.
That's
It is.
what
It
we
is the
have
same
discussed in the email list.
for the
That's what we
maximum
have.
latency. For the guaranteed latency, it is the same. Of course, TSN ATS has no delay when there is no competing flows, whereas in because we're using a damper now, in GLBF the latency is always as long as the maximum latency.
Yeah, but I have given you a counter example. Please revisit my email.
I think we're
Okay.
moving beyond clarification. Probably to take this to the list.
Thank you.
Thank you. Okay, so Turtles, what I'm going to do is I'm going to put the ECQF eval revisited on hold.
Yep.
Xiaofu, have you managed to overcome your network propagation difficulties?
Hi, Doctor. I'm sorry for that. It seems that my network is not stable. Um, just during this period, I have lost so many times from the server.
Okay, let me
Maybe
see.
I can try to.
Uh-oh, here we go again. right.
Ask for recording.
All right, is there, Shafu, can you present the slides, or can anyone else walk us through them?
Hi, I have seen the screen. I think I may try to represent these slides. I'm sorry for that.
Okay,
Okay, for I think I will go to the 3.3. For
go ahead.
so I'm sorry for that. The network is not stable.
I suppose I can slowly page through the
Uh,
slides.
yeah, if you can tolerate this issue, so I can try to go ahead. For the 3.4, for this item, the evaluation is also partial. Because for the dynamic mechanism, for each delay level, the delay resource is limited according to the scalability condition. And okay, the unused bandwidth of the high delay level can be used by the low delay levels or burst effort flows. So for the next 3.6, prevent the flow fluctuation. The evaluation is yes. I think flows are permitted based on the resource reservation of delay levels and isolated flow mediat. And the next one, 3.7, be scalable to a large number of hops with complex topology. This evaluation is partial. Because more buffer may be needed when the latency compensation plus in time is used. However, in other options, this issue it has no disease. Okay, please go to next page. So this is some further explanations of the for the 3.3 accommodate the higher link speed. We can consider this item from two aspects. The first is buffer cost. So for given server state amount of requirement, and we can use the minimum delay level provided can be correspondingly smaller. Otherwise, burst resource of delay level, for example, DI, if its duration remained unchanged independent of the link speed, it will be proportionate to the link speed. Thus, the higher link speed, the more burst resource provided and the more buffer size needed. If the total amount of buffer resource of hardware is limited, only a smaller number of round-robin queues can be provided, which again means that the maximum delay level is limited. So in brief, it is related. Okay, just lost again. So for the processing cost, the instructions of microcode will include first calculate the allowable queuing delay, and the second is rewrite the latency deviation. So the first aspect is state cost. There is no state per flow is maintained on the nodes. The state, for example, the planned response time and the delay deviation is carried in the packet. And the overprovision aspect, the burst resource and bandwidth resource pool of each delay level is limited and derived from schedulability conditions and cannot support flow scales exceeding the pool size. The following is example. So there is no overprovision. It doesn't take the calculation result of burst divided by the delay level to get an overprovision bandwidth. And the aspect that is to support more delay levels, or they may be explained as traffic classes, we can flexibly define new delay levels on demand to achieve high utilization. That means also each delay level has only limited burst resource. More burst resource can be provided by defining more delay levels to admit more services. Note that the minimum delay level is still be the most expensive. For the path calculation, I expect the calculation is not per flow, but is per path that is shared by multiple flows. Next, please. So for the 3.6 prevent flow fluctuation, the evaluation is yes. Volatile levels have their own resource pool isolated from each other. Resource reservation is accepted at the granularity of a path and is not and is assumed that the workflows of the same delay level arrive simultaneously and match the node without exceeding the deadline. That is, the amount of eligibility arrives is always meet the scheduling condition, in despite of flow fluctuation. And the 3.7, for this item, we can consider from the following aspect. first is pass calculation. The calculation is simple, only to check the source of each link dependently, no, sorry, independently, to see if it is enough. The burst accumulation, a flow may traverse a path with a large number of hops. For interim mode, it may produce more accumulated burst at the remote hop and need more buffer. We'll give an example in the draft to show that it's related with the hop count. But for the interim mode, it has not this issue. For the end-to-end latency, the formula is hop count multiplied by the delay level, which is perfectly relationship or a line relationship. And for the end-to-end jitter, the latency composition can be used to reduce jitter for each delay level. We can, for example, we can consider the if node. The worst case is that water delay levels have the full traffic and discharge flood water at the same time. However, in reality, the service flow of the output port facing the destination customer may only involve one delay level, so the jitter may be only 180. For example, this is 10 microseconds. Thank you. This is for the comments.
So I think so when Xiaofu comes back, I think the best thing to do is let's see if we can get through this set of slides.
Okay, so I'm sorry, I just lost again. This is for TQF evaluation. So for the first item, 3.1 is tolerate time asynchronous. The evaluation is also yes, it is just need the frequency synchronization. And the second, 3.2 support large single hop propagation latency. The evaluation is yes, because the time slot mapping is independent of the link propagation delay. And the 3.3 commented the higher link speed, the evaluation is partial. The higher service rate, the more buffer needed for the same time slot length. And the next 3.4 be scalable to the large number of flows and tolerate the high utilization. This evaluation is also partial. Calculation passes for as many for fluctuation. The evaluation is yes. Flows are permitted based on time slot reservation, isolated from each other through time slots. And the 3.7 be scalable to large number of hops with complex topology. The evaluation is partial because calculating TKF passes for all services is a hard problem related to hop counts. Next, please. So this is some further explanations of TQF for 3.3 accommodated the higher link speed. We can consider in the following two aspects. The first is the buffer cost. So for a given service data amount requirement, the time slot length of the orchestration period instance can be correspondingly smaller. Otherwise, burst resource of each time slot is proportionate to the link speed. Thus, the higher link speed, the more burst resource provided and the more buffer size needed. In the case of limited total buffer of hardware, only a smaller number of round-trip queues can be provided. That is, scheduling period of all PIFO is relatively short and may affect the success of path calculation for flow interleaving. Processing cost for round robin, there is a simple calculation that is to calculate the scheduling period outgoing time slot by orchestration period outgoing time slot mode M. For PIFO, we should compute the rank for each packet. That is according to the ideal outgoing time slot and deviation and orchestration period length and time slot length. So for the next 3.4, be scalable to the large number of flows and tolerate high utilization. First, the state cost. There is no state per flow is maintained and okay, the first state cost, there is no state per flow. For the next overpollution, there is no overpollution. It does not take the calculation result of burst divided by time slot to get an overpollution bandwidth. And support more layers, that is, we can support multiple orchestration period lengths. Each is LCM of the server's bus interval, and naturally servers okay. They give an example to use multiple OP instance for different service bus interval. For the path calculation, the calculation may be NB hard to find a path meet the expected end-to-end latency. For example, some nodes may contribute less in latency time budget, but some other nodes may contribute more latency time budget. However, the total latency of the path meet the total budget. So in brief, the resource reservation result of multiple links will affect each other. That is not as simple as that we just see in the deadline mechanism. Next, please. So for the 3.7, this evaluation is also partial. We can consider in the following aspect. First, path calculation. Okay, the path calculation may be NB hard that is related to the hop count. And the burst accumulation. So we can support the interim mode for TIGA for mechanism. Okay, for interim mode, it may have burst accumulation or the hazard node. for end-to-end latency, for end-to-end latency, the end-to-end latency of candidate path is based on the reserved time slot resource. So the probable latency may be different due to different offset, which must be less than or equals to the budget volume. So the following gives the end-to-end formula. Is not shown in this slide. I will give in later version. So for end-to-end jitter, the jitter is also good for the ideal arrival position of utilization period of a UNI pod. The end-to-end jitter is only 2 times root and independent of hops. Okay, sorry, this is I'm sorry for this. Tonight the network is so stable. Any comments?
Any questions? Clarification only, please. Janu, let's try it. We'll see if Xiaofu's audio cooperates.
Yes. Thank you, Xiaofu, for the very detailed and elaborate considerations and the presentation. I have a similar question to you again. If you go to slide number 3, you gave the expression for the end-to-end latency bound. As far as I remember, it is hop count times delay level d, right? And times d. My question is again similar. Can
Yes.
you make d arbitrarily small? That is, if d is arbitrarily small, can you guarantee? Or you have to make it sufficiently large to accommodate all the flows and bursts? That's my question. Thank you.
Okay, let's see if his audio comes back. There he is, we hope.
I'm sorry. Hi, Jiru. I don't hear your problem just now. So can you just quickly repeat your question?
Okay. I will make it short and very concise. The n times d, it is the end-to-end latency bound. But my question is, can you make d arbitrarily small? Or should it be sufficiently large so that it can accommodate the number of flows and the bursts coming
Not
from
sure
all
if
the
you
flows?
hear me.
Yeah. Did you get it?
I'm sorry, I just lost.
I tried typing
Okay.
questions to chat, Janu. I hope I got it right.
Okay, I will see the chat.
That's correct. That's correct. Thank you.
Does it depend on the number of flows? For the upbeat.
Okay, any other questions for Xiaofu? And maybe we need to type them into chat. Yeah, I think we're done here. Thank you, Xiaofu. Let me open up the floor. Okay, thank you. Let me open up the floor for any other comments, questions, suggestions before we go back to the ECQF evaluation topic that Turles wanted to talk about. Sean, go ahead. I hope I pronounced your name correctly.
Thank you. I noticed that there are many explanations about the same requirement. For example, the requirement 3.7, there are three different explanations for 3.7. For example, the Gino explains that it's the linear relationship with the latency and the hop count, and Thomas explained that is flow interleaving, and the software is explained that is about the path calculation. So I think if we should first do some alignment with the requirement explanations for the different tuning mechanisms.
It certainly seems that the requirements draft could use some revision, particularly in the area of 3.7, where I think I see a similar theme of teasing that requirement apart into component elements.
Yeah, I think it's not just the 3.7. I think, for example, the 3.4, there are 4 aspects over the explanations in selfish evaluations. So I think we should summarize and collect the different explanations and do some alignment.
I think that would be good. Would hope that the requirements draft authors are prepared to lead this, would be happy to make time available in the next meeting to try to come to conclusion if that's helpful.
Yes. Okay, I will discuss with the authors. Thank you.
Okay, sounds good. Turles?
Yeah, I think the main in my slides there are some the few main points, right? So the I think the most complex one would be 3. What the now I forgot the numbering. The one about the aperiodic flows, right? I think it would be good if we all try to understand how to do that, and maybe we can just also write some additional text to explain it.
Mm-hmm. Jundong?
Yeah, regarding 3.1.4, I totally agree with Torres on this item. The text of this section, 3.1.4, is really talking about non-periodic traffic flows, which require to be supported expected with a better mechanism than 802.1 QCR. So I'm really in support of Tolle's proposal here. Thank you.
Thank you. Okay, please watch the list for discussion of how to update the requirements draft. As I said, I'd be happy to make time available in our next open meeting if we have some proposals that need to be discussed for how to do it, or requirements draft can just be updated. Any other comments or questions? Janu?
Yeah, I have quick comments on the Torres suggestion regarding the per hop latency and per hop jitter. So end-to-end latency bound and end-to-end the jitter bound is very important. We all know that, but I'm not so sure about per hop jitter or per hop latency bound itself, or the requirements regarding such an aspect is necessary. I'm not so sure. Thank you.
Can I answer?
Sure, let's go ahead, and then I might or might not have a comment depending on what you say.
Yeah. So that I had a slide where I was showing the suggested evaluations, and what I had in there is that the per hop jitter, that ultimately it is
Hang on a
evaluation.
minute. Hang on a minute. Give me a slide number and I'll put it up so we can talk about the slide you want to talk about.
Oh, what's the number? Yeah. Sorry.
It looks like it's slide 5. Let me check if it's this one. If it's not,
Yeah.
tell me where to go, please.
Yeah, it's slide
Hang
5.
on. It is slide 5. All righty. Now we just have to convince Meet Echo.
There may be other useful things which we do agree or disagree on this, and I think that slide may be
This one.
useful. Yeah. Yeah, exactly. So I think that would be good if we could come to agreements of how we evaluated this, right? So this is what I used for the 3 drafts that I presented, and this 381, the per hop jitter or so. The whole point is that the end-to-end jitter is independent of the number of hops in the path, right? So when we have more and more hops, then the jitter shouldn't increase with the algorithms. Now, it is clear that we can always do a de-jittering function on the egress node if we do add a mechanism for that. But the mechanism for that would require an additional, let's say, ingress to egress timestamp and then de-jittering on the egress. If an algorithm proposes to use that, then I think we should have text for that. I think we did brainstorm a little bit that. And of course, there is still the problem that the de-jittering buffer on that hop now needs to be scaled depending on how large the network is. So you're starting to create another PE requirement that people have to investigate and say whether that is a better solution, right? And there needs to be clock synchronization between ingress and egress. So there are alternatives, but ultimately it is not to increase the jitter when the network becomes large. That description of that requirement. Yeah. And you know how important that requirement is compared to the others. I think by this point in time, it should be clear to everybody that there is no ideal algorithm that solves everything ideally, but I think we should understand the requirements as the aspects on which we evaluate and then draw our conclusions.
And the comment I was going to add is that what you described about allowing allowing the delay bound to be linear in number of hops, but have an end-to-end bound on jitter, I think is consistent with what Tron posted to the list late last week.
So far, I just, used the trick that I think Yizhu also did initially with 341 and 342 in terms of interpreting the requirements as something that already exists in 3.8, right? So 3.8 does talk about the different type of traffic, and obviously low jitter is specifically important to the tight control loops, which are periodic. So, but obviously we can also move that into a new point if that is easier. And I think some of the co-authors indicated that already.
Tron?
If this is optional requirement, and for the surface with the tight jitter, we should not tight jitter, just end-to-end jitter. It should be required to be independent of number over the number of the hops. But if the surface that does not require the end-to-end tighter, just the end-to-end jitter, just lead the end-to-end latency, then it's not must necessary requirement. And for the end-to-end jitter requirement, I think it also can be divided into two aspects. For the surface with the tight jitter requirement and the untight jitter requirement. So I think it's an optional requirement, and it can be divided into sub requirements.
Yeah, I wouldn't worry too much about mandatory versus optional requirements. I'm going to go back to something Torlis said. There is no algorithm that is going to completely meet every single one of these requirements. We're going to wind up doing some kind of engineering trade-off on which ones are more important, where we can compromise and why.
And maybe it's more important that we also arrive at things like, if some network, for example, only wants to do something in the order of QCR or other fully in-time mechanisms, then we do need to define this dejittering function for the network on the ingress and egress P, and have according additional new network packet headers, right? So it involves, I think, writing text that we haven't done so, right? I'd be happy to do that, but then I think
I will also
much clearer to compare the complexity of both of these solutions.
Okay. Shinu?
Yeah, my question was, is there any application or external requirements that suggest the per hop jitter or per hop latency is important regarding the external requirement or the application, not the technical ones, just you have described, but the application side. That was my question. Thank you.
I think it's the as I tried to explain, we can discuss on how to phrase the requirement. Doing it on a per hop basis is just an expression of the ability to provide network size independent end-to-end jitter without requiring an additional ingress and egress PE dejittering function. So that's kind of a network operator deployment benefit, that he doesn't need that additional function.
Yeah, I agree with that aspect. But on the other hand, you have to understand the whole network as a single
Of course.
thing. Yeah.
No, and I've been making the argument,
There's
for example.
such a property called pay burst only once.
Mhm.
So if you want to break down the network into hubs, you will likely end up without having that benefit of that property, pay burst only once. So I would suggest to look the network as a single whole thing rather than hop by hop aggregated devices. That's my suggestion. Thank
Oh,
you.
I completely agree. And I was making exactly that argument when I was talking about the support for the aperiodic flows and not incurring large buffering on a per hop basis, but with TCQF, CSQF having shallow buffers on every hop, and then incurring the burst delay only once on the ingress PE as an ingress PE function for that benefit. So I think the argument goes either way, and I think we just need to be clearly expressing the options.
I think more to come. It sounds like the jitter aspects of the requirements draft are going to get some significant revision. Zhendong?
Would you please show Torres slide?
Yeah, sure, I can do that. You want the one I just had up, right?
Right.
Just a minute. That should be it.
Yep. Go to previous slide. I mean the forward, backward. No. The other way, the other direction.
This
One more.
this
No,
one?
no, no. I'm sorry. Anyway, it's the third page. Page 3. Enhancements to evaluation sheet. Up. Yes. Yeah. I have question about this. The first bullet item here. It says new column to indicate whether requirement is per hop or ingress. I'm not sure if we can indicate whether requirement is per hop or ingress. In my understanding, a requirement applies to .NET data plane as a whole, regardless of ingress or per hop. Maybe a solution can be per hop, which may mean every node in a network is required to implement this solution or something like that. So I'm so I'm not
Maybe,
sure.
Jian,
Yeah,
so
go on.
maybe
Yeah.
let me rephrase the expression. I think the column is meant to indicate whether a proposal wants to supports this through a per hop function or a PE function, right? So the
Okay.
right. So if it's on a PE function, we know that it doesn't impact the complexity of every. So typically, the forwarding speed required for p-hop functions is a factor 10 or more higher and faster than for the PE functions, right? Even if you have a ring and every router is P and PE, only a tenth or so of the overall traffic needs to deal with PE functions, right? So that makes a big difference. And I think that helps the evaluation. And I think it also helps us more to understand that just because a hop by hop mechanism doesn't do something, we can add it to the mechanism as an edge function. And I think we talked about specifically two options here, right? One is to shape bursts on ingress to get higher utilization, or to reshape traffic flows on egress to eradicate jitter, right? So those seem to be, for utilization and jitter management, the two edge functions that either algorithm needs, right? So one algorithm does seem to need the ingress shaping so that we get higher utilization with lower latency ultimately, and the other algorithms, the in time, they need shaping on egress to eradicate jitter, but ultimately that may still lead to higher end-to-end latency. So those are the tough comparisons.
Well, I still don't understand. Then this P and PE is really for a requirement, or is it for
For the
solution?
evaluation. For the evaluation, right? So the column should indicate for the evaluation whether the requirement is resolved in the proposed mechanism as a per hop behavior, or as an ingress, or I think in the future as an egress PE mechanism.
So this
If you're
P and
looking,
P.
if you're looking for an analogy, you might take a look at diffserv, which draws a very strong distinction between what is done at the network edge and what is done in the network core. The per hop roughly is network core, and what Trudeau is calling ingress, and he really means ingress or egress, I agree, is edge processing.
Mm-hmm.
Yeah, I understand that, but that's property or characteristic of a proposed solution is not the not.
Absolutely correct, and perhaps the requirement word is not what should have been on this slide.
Right.
Okay, yes. Then it's not for requirement. It applies to solution.
Correct.
Right.
It's
Right.
basically indicating whether the requirement is met via a per hop or an
Oh,
edge
okay.
mechanism.
Yeah. Yeah.
Okay, then
Sorry,
the
slides had to be assembled very quickly. I put a deadline on people, so this happens.
yeah, then I should suggest move this P and PE column after just prior to nodes, not
Oh, okay.
not
Yep.
not
Yeah.
as besides
I'm more,
requirements. Okay,
I'm,
okay, thank you.
I'm more concerned with slide content than whether than which column was in which order. But yes, understood. Okay, Turles, you want to take the last about 10 minutes to quickly do the comments you wanted to make on ECQF?
Yeah, but probably, given the audio quality that we have, probably just a starter for what we need to take to the list to get a good discussion, I fear.
Well, okay, if you could quick skim through it. You went to the trouble of presenting it. I think we have the time to do it, so let's go ahead and do that.
Yeah, so
Oh,
I was looking through ECQF, and maybe I'm misunderstanding something, which is fine, but the whole point really is that ECQF does not eliminate any of the requirements against the clock accuracy as far as synchronization that did exist in CQF, and because the arrival time based on the receiver clock is used to assign the cycle, and that is the core limitation when you do not have a packet header. Now you need to be worried that there is no difference between what the sender thinks is a valid sending time for the cycle and what the receiver thinks is a valid reception time for the target cycle. And as soon as there is a jitter between these two, you start to assigning packets to the wrong cycle. And you can only eliminate that by increasing the dead time again. So you're not using some percentage of the sending time that you actually have to send packets. And that, increase of dead time is, of course, what we never want to have, and which is obviously very easily avoided by doing the indicating the cycle in the packet header, which is the core difference between our solution and the TSN solutions, right? And of course, then comes also the problem that as soon as we go faster than the 10 gigabit per second that TSN is really targeting, when we go to 400 gigabits or so, then we deal with a much larger increase in variability of any type of clock measurement also within a node, right? So the routers that we're looking at are really networks of smaller routers, right? Each ingress and egress line card can be separate router, fairly asynchronously connected to through a fabric. And there can be a lot of variations in propagation latency through the ingress line card, and all the algorithms we're looking into ideally only need to work localized in an egress line card. And so it would be ideal if we do not need to capture and synchronize the clock across the whole router, but only so. There are really a bunch of details, and I think we're trying to get closer and closer of trying to understand and express them. But that's as good as I think we've gotten so far in expressing that the assumption that the clock on arrival of a packet can be accurate enough to derive the cycle number from is really not working for higher speed networks and more larger scale networks. And of course also to be reminded of CSQF by mean of giving the network controller the ability to indicate one out of potentially 10 possible receiving cycle has a much broader way to shape also potential bursts and let the controller decide that. So that's yet another core benefit. And we try to indicate that a little bit through the evaluation, but of course there is a good question of how to maybe even better express that to the requirements. That's all.
Oh, okay, that was the reference chart. Okay. All right. Any other comments or questions in the last few minutes? All right. Thank you very much, everybody, for taking the time to attend. I hope this has been useful. I think the most immediate thing that needs attention is the requirements draft follow-up based on some things that have been discovered in doing these initial evaluations. Thank you all very much. I think we're done.
to send the packets from D to F. Noch ein paar Minütchen und dann rufe ich zurück, okay?
Darf ich schon aufs Klo gehen?
Auf jeden Fall.
Danke. Die gemessene Temperatur beträgt 36,4 Grad.
Yep, yeah. Moment, ich rufe zurück.